Hello, it's very early or late. This is my linked list implementation. So this is again the superclass, my list. These are the 9 functions. I had to comment this one because to serve its purpose, it has to be implemented differently. And in order to be implemented differently, it cannot be declared here because here it requires an operator. Or I don't know what that's called, like a return type, because the search returns a type. And so for arrays, it's ints, but for linked lists, let me show you. Linked list, it returns nodes. So it was giving me errors, so I just commented it out over there, and I made it like this here, and then like this here, where search. Oh, it's right here. Int. And so this is the superclass, subclass. These are the full 10. Sort was very tricky, but I got it. I was able to do it. And then these are the actual definitions of the functions. And then over here is where I actually test everything. So append, display, prepend, and then contains, get length, insert after, testing whether insert after does return true or false, and if it operates accordingly. And then the other ones do work also. I have full confidence, but I just decided to move on to testing whether the sort works, and then decided that I needed to make the video already. So the first function I'm going to go over is going to be the display. So the way display, I want to focus on these last 3 lines. So the functions in these last 3 are display, sort, display again. So the way display works is that it starts at the head. So the difference between an array and a linked list, array, you know where everything is. So you can use for loops because you know where it ends. But a linked list, you have to use a while loop and just kind of like move until you hit a wall, like you're blindfolded and you're just walking forward. And so that's why you can only start at the head. You could start at the tail, but it wouldn't work because you can't move backwards. So you have to start at the head. You can't start anywhere else. You have to start at the head. You could start at the head or the one right in front of the head, but that's it. It would be like convoluted to make it. I'm getting ahead of myself. You have to start at the head, and then through each iteration at the end of it, you have to move on to the next one. And so that's how it's able to continue. And so the only thing you have to put as the parameter is the current node, because eventually the current node will be set to equal to the null pointer, and the null pointer is an equivalent false. That's what breaks out of the while loop, and so it ends. And then I include this because so it can be a different line. That's why I did that. So that's how display works. The one that was really hard was sort. The purpose of this is so that, because this is a list of items, you want to be able to see your list of items whenever you want. So when you call on this function, it'll just display everything for you. You don't have to like hard code it every time. It's annoying. But this one was strange. I was getting errors because the way I did it is I'm going to go over the time again. I'm sorry. I'm making like a fake beginning, which I move every time. And so I also need to compare the fake beginning with the fake beginning's neighbor. But the issue can happen is if you only have a list that has like one value, then you can have a fake beginning, but you can't have a fake beginning neighbor, and it'll give you errors. Also, if you have like a null pointer and you try and point to the null pointer's next thing, it'll give you errors. So I had to say if it has stuff work, at least 2 values. It has to have at least 2 values. So I could have set it length greater than or equal to 2. I don't like how that looks though. And like I said, yeah, you set the false head equal to the head, But the reason why it has to be the false head, or the reason why I say that, is because I'm going to be moving it, and I don't want to move the head and then forget where the actual head was. So leaving the head alone, but making a false head is why I did that. And then current smallest, I don't know how Zybooks implemented the sort. It crashed before I could look at it, so I did it like this. Current smallest is equal to the false head, so you're assuming the first value is the smallest, and then the current node you're going to start next. So I think this is insertion sort, where I swap the smallest value every time. So you assume the sorted part, that value is the smallest part, smallest value, but then you're going to look in the unsorted part and check if there is a smaller value, and if there is the smallest value in the unsorted part, you're going to switch them, and then you're going to move the false head over. So that's what this part is. So it's a nested while loop, so it's n square. And so if the current node's data is smaller than the current smallest node's data, which we initially assumed to be the first value, then we switch them. Current smallest is equal to the current node. And you could say like, oh, why can't this be why do you have to be moving around nodes or whatever, or node pointers? It's because, how do I put it into words? I did it a little bit ago. Over here, to swap them, so you could put the false head's value to be the smallest value, that would be an int, but then to put the false head's value back into the smallest ones, where you wouldn't be able to find it, so you need to have it be a node that you can call on and say, oh, here. So that's what this line is. Current smallest data is equal to the value. The value is just a placeholder. I could have named it placeholder, I didn't. And so these three lines are the swapping. And then these three lines are like the I++ of a while loop. It's setting up all the things for the next time. So it's making the false head the next one, assuming that that value is, again, the smallest value of the unsorted part, and then starting right after that. So, and then also, if false head is a null pointer, don't ask to look at the null pointers next. So if it isn't a null pointer, then you can ask current node is equal to false head next, and then it'll move on. And if it's not, then it'll just break, because false head is a null pointer, and it'll finish. And let me show you it working. So it's these last two lines where it works. I inserted values willy-nilly, 22, 101, 39, 38, blah, 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 blah. And then it correctly sorts them. Very proud of that. I don't know if that's proper implementation, but I assume I think it's fine. Thank you very much.